Hello everyone, welcome back to our channel. In our earlier episode, I have discussed the primary sources of noise in Raman spectra and the strategies to mitigate them. If you missed those episodes, you can find the link in the description below or click the card in the video. Today and in the next video, we will explore the data processing technique to reduce the noise in Raman spectra. Let's consider a Raman signal represented by two peaks in the spectrum. This peak has a specific width and spans several data points. Noise, on the other hand, is random and varies from one data point to the next. Our goal is clear. We aim to remove the fast-changing components from the point-to-point while preserving the slow-changing components. To achieve this, we use a narrow window to analyze small sections of the spectrum at a time. Within each small section, we can observe noise, but the window is too narrow to capture entire Raman peak. By performing calculations on this small section and then moving the window to the next part, we process the spectrum incrementally. For simplicity, let's calculate the average value within the window and then move on. As a result, the moving average spectrum exhibits less noise. However, the Raman peaks become lower and broader. Additionally, at the end of the spectrum, this method is less effective due to the insufficient data. These limitations can be addressed by applying more sophisticated techniques, such as the popular Savitzky-Golay method. Even so, no algorithm is perfect. All methods affect Raman peaks, particularly sharp and closely placed peaks, making them broader and lower. Selecting appropriate window width is crucial. The window must be large enough to be effectively smooth the noise, but small enough to preserve the Raman peaks. As part of the data processing chain, changes in algorithms or parameters can influence the following evaluations, such as peak searching or peak fitting. For this reason, some researchers prefer to enhance the signal-to-noise ratio solely through experimental parameters, such as longer exposure times, to avoid applying smoothing algorithms to the raw data. Is it possible to overcome these issues with a technique that doesn't rely on a moving window or require additional measurement time? The answer is yes, and we will discuss this approach in the next video. Stay tuned.